A यदि फर्स्ट है या B यदि सेकंड है या B यदि फर्स्ट है A सेकंड, दे आर डिफरेंट थिंग. सो कोई कोई केसेस में अरेंजमेंट मैटर करता है और किस किस केस में अरेंजमेंट मैटर नहीं करता है. जब कॉम्बिनेशन में क्या होता है, अरेंजमेंट मैटर नहीं करता है. जैसे कि और जस्ट बता रहा था तुम्हें कि जैसे कि दोनों को गिफ्ट मिला, देन मुझे नहीं पता है कि 10 में से इन दोनों को गिफ्ट मिला है कौन से, किसको फर्स्ट किसको से, दैट आई डोंट वांट टू नो. ठीक है, बट उनको गिफ्ट मिला तो इजी. ठीक है, तो इसे फाइन combination. So formula NCR, that will be equals to n factorial divided by r factorial. Okay, so ये formula है. Okay, then definition of the probability of an event to be. Okay. The probability of an event A is the sum of the weight of all sample. Okay, so so probability of A that lies between 0 to 1 and probability of phi that is equals to 0. That means phi means any empty element is there. So then that is equals to 0. And what is P? Probability of S, that is the sample space, because R is contains all the elements, so that's why probability of S that is equals to 1. And if you want to find out any interval, so probability of A that lies between मतलब कि कोई भी इंटरवल तुम दे दो तो उसके हिसाब से हम लोग फाइंड आउट कर सकते हैं. ठीक है, just 1 minute. ओके, देन नेक्स्ट इज ये हो गया कॉम्बिनेशन का. नेक्स्ट प्रोबेबिलिटी ऑफ एन इवेंट. सो ये प्रॉपर्टी हो गए. देन प्रोबेबिलिटी ऑफ इवेंट में 3 प्रॉपर्टीज है. ठीक है, 3 प्रॉपर्टीज है, उसको ध्यान दे देना थोड़ा. Then another way of defining the probability, that is equals to probability of A that is equals to n by n. Probability of A equals to n by n. That means जो भी तुम्हारा मतलब कि फेवरेबल इवेंट है, मतलब कि फेवर कर रहा है तुम्हें, तो दैट इज इक्वल्स टू स्मॉल n divided by the total number of events. So this one. Then additive rules and other related terms are there. ठीक है, तो वो सब फॉर्मूलेज है, वो तुम लोग देख लेना. एक इम्पोर्टेंट प्रॉपर्टी होता है कि प्रोबेबिलिटी ऑफ ए प्लस प्रोबेबिलिटी ऑफ ए डैश दैट इज इक्वल्स टू 1. So probability of A is equals to probability of A that is equals to 1 minus probability of A dash. So इस तरीके से ये कुछ प्रॉपर्टीज है. Then okay, then ठीक है, यहाँ तक कोई डाउट है किसी को? यहाँ तक देखो, कॉपी ओपन है, तो किसी को कुछ डाउट है तो पूछ लो. आई विल जस्ट गिव यू 1 or 2 minutes. यदि उसके अंदर कोई पूछता है तो ठीक है, नहीं तो मैं फिर प्रोसीड करूँगा. ओके ठीक है, नेक्स्ट प्रोसीड करता हूँ मैं. दैट इज द ये हो गया. नेक्स्ट इज द कंडीशनल. सो कंडीशनल प्रोबेबिलिटी एंड इंडिपेंडेंस एंड द प्रोडक्ट रूल. ठीक है, ये सब पढ़े थे हम लोग. फर्स्ट इज द कंडीशनल. Conditional probability, that is probability of A given B, that is equals to probability of A intersection B divided by probability of B. हाँ ठीक है. So और similarly probability of so multiplication rule यहाँ से आता है. probability of A into probability of A given B, that is equals to probability of A intersection B. Okay, so ये आ गया तुम्हारा मल्टीप्लिकेशन रूल. ठीक है, एंड यदि दोनों इंडिपेंडेंट है तो क्या होगा कि प्रोबेबिलिटी ऑफ A गिवन B, यदि इंडिपेंडेंस की केस में, इंडिपेंडेंस के लिए क्या होगा, प्रोबेबिलिटी ऑफ A गिवन B that is equals to probability of A itself, because it will not depend on this B. Okay, so probability of A itself and the probability of A intersection B, so this will be equals to probability of A into probability of B. Fine. ओके, तो कल ये बहुत लोग गलती किए थे. ये क्वेश्चन में पूछा था ये प्रोबेबिलिटी ऑफ A गिवन B इक्वल्स टू क्या है, या प्रोबेबिलिटी B गिवन है क्या होगा इफ A एंड B आर टू इंडिपेंडेंट इवेंट्स. तो बहुत लोग, ये भी कुछ लोग लिखे थे करेक्ट. क्वेश्चन थोड़ा पढ़ लिया करो अच्छे से, नहीं तो फिर बहुत मार्क्स कटेगा तुम्हारा. देन मल्टीप्लिकेशन रूल हो गया, बाकी तो हो गया. Next is the base rule. बेस रूल. सो बेस रूल, और उस बेस रूल के अंदर में आता है दो चीज. वन इज द टोटल प्रोबेबिलिटी, okay, so total probability, that is the total probability theorem है क्या कि यदि तुम्हारे पास कोई सैंपल स्पेस है, yes, so we just partition it into, okay, partition it into smaller regions. ठीक है, such that the intersection is fine. तो यहाँ पे देख सकते हो कि किसी का भी किसी के साथ इंटरसेक्शन नहीं है, तो इंटरसेक्शन that must be fine. Then if you define any event, okay, if you define any event, then what is the probability of happening that? तो मान लो ये हो गया तुम्हारा E1 E2, so yeah, B1 B2 B3 B4 B5 B6 B7, इस तरीके से बहुत सारे एलिमेंट्स आते हैं, बट दैट विल बी मोर. सो इज नंबर ऑफ एलिमेंट्स है, तो टोटल प्रोबेबिलिटी वहां पे कैसे फाइंड आउट करोगे. ओके, सो टोटल प्रोबेबिलिटी मींस सिंपली द प्रोबेबिलिटी ऑफ A, probability of A. So probability of A, that is simply the summation of this intersection paths. Okay, so that's why this is equals to so this is equals to summation of probability of probability of bi into probability of a given bi equals to 1 to 3. ओके सो ये टोटल प्रोबेबिलिटी इस केस में 1 to 3 है या 1 to के मान लो इन जनरल, ठीक है, 1 to के. सो इस तरीके से हम सॉल्व करते हैं, ठीक है. टोटल प्रोबेबिलिटी एंड क्या है, एक है बेस रूल. बेस रूल में क्या आता है, यहाँ पे प्रोबेबिलिटी ऑफ ए है और वहां पे सिर्फ होगा प्रोबेबिलिटी ऑफ बी आई गिवन ए. हाँ, probability of bi given a, so that will equals to probability of bi intersection a divided by probability of a, ठीक है. फिर आता है probability of bi intersection a probability of bi into probability of a given bi divided to probability of. ये प्रोबेबिलिटी ऑफ है जो टोटल प्रोबेबिलिटी से फाइंड आउट किया था, इसमें डायरेक्ट पुट कर दो तो तुम्हें आंसर मिल जाएगा यहाँ पे. सो ये हो गया बेस रूल एंड टोटल प्रोबेबिलिटी. यहाँ तक किसी को कुछ डाउट है, कोई प्रॉब्लम, जैसे कि कुछ भी बेस थ्योरम में कुछ का डाउट रहता है, किसी को डाउट है तो 1 or 2 मिनट्स देता हूँ, तो तुम लोग थोड़ा देखो, किसी को डाउट है तो पूछो. क्या रिवीजन का कुछ समझ में आ रहा है, कुछ हो रहा है या नहीं, क्या ऐसे मैं बके जा रहा हूँ? किसी को कोई मतलब कि डाउट या कुछ भी नहीं, सारा चीज क्लास में समझ में आ गया था? हाँ, अभी तो प्रॉब्लम वगैरह सॉल्व किया हो या नहीं कोई?
किए हैं सर.
तुम तो किए हो, मैं जानता हूँ, बस छोड़ो, बाकियों के पूछ रहा हूँ. मतलब बाकी एटलीस्ट कुछ नहीं, तुम तो डाउट एटलीस्ट पूछ लिए थे कुछ, बट अभी कोई कुछ भी नहीं बोल रहा है. तो
हाँ सर, वो मेन चेविसेस में दिक्कत है, बाकी कहीं नहीं. ठीक है सर.
चेविसेव का हो गया ना?
हाँ सर, वो क्लियर हो गया था सर, वो एक्सप्लेन कर दिए थे उसके बाद.
ओके ठीक है, तो फिर
ठीक है सर.
ओके ठीक है, तो फिर तो कुछ बोल नहीं रहा है तो मैं जस्ट नेक्स्ट टॉपिक को चला जाता हूँ. रैंडम वेरिएबल. रैंडम वेरिएबल रैंडम वेरिएबल. सो रैंडम वेरिएबल में क्या क्या टॉपिक्स था कि बर्नौली रैंडम वेरिएबल क्या है, पहले हम पढ़े थे. डिस्क्रीट क्या है, डिस्क्रीट एंड कंटीन्यूअस रैंडम वेरिएबल. डिस्क्रीट एंड कंटीन्यूअस रैंडम वेरिएबल, ठीक है. देन मतलब कि जो प्रोबेबिलिटी मास फंक्शन, इन केस ऑफ डिस्क्रीट वी कॉल इट एज ए प्रोबेबिलिटी मास फंक्शन, एंड इन केस ऑफ continuous case we define it as a probability mass function, PMF लिखते हैं. in case of discrete and PDF कहते हैं in case of continuous, ठीक है. प्रोबेबिलिटी डेंसिटी फंक्शन, प्रोबेबिलिटी मास फंक्शन, ठीक है। और मास फंक्शन के कुछ प्रॉपर्टीज थे, सो दैट इज f of x is less than equals to 0 and summation of fx is equals to 1, ओके। एंड fx का मीनिंग क्या है? f of x का मीनिंग ये है कि प्रोबेबिलिटी ऑफ x इक्वल्स टू x, इस तरीके से। देन एक आता है कि CDF, दैट इज क्युमुलेटिव डिस्ट्रीब्यूशन फंक्शन। सो क्युमुलेटिव डिस्ट्रीब्यूशन फंक्शन क्या है? f of x दैट मस्ट बी, ओके हाँ, यहाँ पे भी सेम चीज है, यहाँ पे भी fx ग्रेटर देन इक्वल्स टू 0 है एंड यहाँ पे समेशन है, तो यहाँ पे इंटीग्रेशन ओवर ऑल x, इंटीग्रेशन माइनस इन्फिनिटी टू प्लस इन्फिनिटी f of x dx, ठीक है। So now comes the CDF, that is f of x, capital F of x, that is probability of x less than equals to x, ठीक है। So that will be equals to summation of all t less than equals to x and f of t, ठीक है। So t is less than equals to x f of t, okay। Then probability density function and it's also CDF, और इन केस ऑफ कंटिन्यूअस के केस में इंटीग्रेशन में आ जाएगा, इंटीग्रेशन ऑफ माइनस इन्फिनिटी टू x f t dt, ठीक है। देन जॉइंट, ओके ठीक है, हाँ जॉइंट डिस्ट्रीब्यूशन है नेक्स्ट। सो जॉइंट डिस्ट्रीब्यूशन में तुम्हारा था सेम जो जॉइंट पीडीएफ में पॉइंट पीडीएफ, और सेम प्रॉपर्टीज है बट विथ टू रैंडम, लाइक f of x, y is greater than equals to 0, summation means double summation x and y, f of x, y is equals to 1, then probability of x equals to x and y equals to y, so that is equals to f of x, y, okay। so ये हो गया PMF, joint PMF। similar way you can define the PDF, okay, joint PDF, okay, joint PDF भी सिमिलर वे में हम डिफाइन कर सकते हैं, ठीक है। देन इसमें से एक कॉन्सेप्ट आता है कि एक है marginal distribution and second one comes the conditional distribution, ठीक है। सो कंडीशनल डिस्ट्रीब्यूशन, मार्जिनल डिस्ट्रीब्यूशन का मीनिंग क्या है कि इफ यू वांट टू फाइंड आउट g of x, so that is if it is continuous one, they have to integrate this from the total जो भी तुम्हें दिया गया है। so g of x is minus infinity to infinity, जो भी उसका रेंज है, यहाँ पे मैं इन जनरल माइनस इन्फिनिटी टू इन्फिनिटी लिख देता हूँ। g of x is equals to minus infinity to plus infinity of f of x है तो f of y to dy, f of x, y, sorry, with respect to dy इंटीग्रेट करो। यदि x यहाँ पे है तो dy के रेस्पेक्ट में इंटीग्रेशन करोगे, यदि y है then x के रेस्पेक्ट में इंटीग्रेट करोगे। then similarly you can find out f of y जो है next x, y g of x, और यदि f of x given y होता h of y, okay। ये तरीका है। ओके, यहाँ तक कोई डाउट?
नो सर।
ओके, ठीक है, एक काम करता हूँ, पहले क्विज ले लेता हूँ, ठीक है, वो जस्ट 1 मिनट। Okay, all of you check that. I have sent you the link for the quiz. So do it.
सर वो शो नहीं हो रहा है सर।
अभी चेक करो ना, हो गया होगा।
हाँ सर, हो रहा है।
ओके, टाइम हो गया तो मैं अभी बंद कर रहा हूँ. ओके, ऑल ऑफ यू सबमिट. तीन क्वेश्चन है, उसको कितना टाइम लगा रहे हो सॉल्व करने में? अभी तक भी बहुत लोग नहीं दिए. जल्दी सबमिट करो हर कोई. हाँ ठीक है, 45 एग्जैक्ट हो गया तो मैं वो बंद करता हूँ. जिसका हुआ नहीं हुआ. ओके देन सो there's some posters और कुछ रिवाइज कर देते हैं यहाँ से. सो मार्जिनल डिस्ट्रीब्यूशन कंडीशनल हो गया. देन और कहा गया चैप्टर 4 एक्सपेक्टेशन का जनरल एक ही चीज मतलब मैं बताया था तुम लोगों को. सो कि एक्सपेक्टेशन, सो एक्सपेक्टेशन में क्या था कि एक्सपेक्टेशन ऑफ एक्स और दैट इज डिनोटेड एज म्यू, दैट इज इक्वल्स टू समेशन ऑफ एक्स इनटू एफ एक्स ओवर ऑल एक्स और इंटीग्रेशन एक्स इनटू एफ एक्स माइनस इन्फिनिटी प्लस इन्फिनिटी डीएक्स. ठीक है. सो और यदि हम एक्सपेक्टेशन ऑफ जी एक्स करेंगे या एक्सपेक्टेशन ऑफ जी ऑफ एक्स करते हैं, इन दैट केस इन प्लेस ऑफ एक्स जस्ट रिप्लेस इट बाय माइनस इन्फिनिटी सॉरी जी ऑफ एक्स इनटू एफ एक्स डीएक्स. तो ये तरीका है. ठीक है, तो इस तरीके से तुम लोग मतलब कि सॉल्व कर सकते हो. ओके देन देन इसके बाद आता है तुम्हारा वेरिएंस. ये जनरल फॉर्मूला है. देन नेक्स्ट इज द वेरिएंस. तो वेरिएंस में क्या है? वेरिएंस के केस में हम लोग क्या सॉल्व करते थे कि जी ऑफ एक्स, वहां पे ये जो जी ऑफ एक्स लिया हूँ, जी ऑफ एक्स इज इक्वल्स टू एक्स माइनस म्यू होल स्क्वायर. जी ऑफ एक्स इक्वल्स टू एक्स माइनस म्यू होल स्क्वायर. ये तरीका है. तो यहाँ पे सिग्मा स्क्वायर दैट इज इक्वल्स टू एक्सपेक्टेशन ऑफ एक्स माइनस म्यू होल स्क्वायर लिखते हैं. ठीक है. So that will be equals to summation या integration minus into cos infinity or all x minus mu whole square into fx x minus इस तरीके से सॉल्व वेरिएंस फाइंड आउट करते हैं. ओके देन if you take the positive square root of this one, then that becomes the standard deviation. सिग्मा. देन एक फॉर्मूला में डिराइव किया था कि वेरिएंस दैट इज इक्वल्स टू एक्सपेक्टेशन ऑफ एक्स स्क्वायर माइनस म्यू स्क्वायर और एक ऐसे दैट एक्सपेक्टेशन ऑफ एक्स स्क्वायर माइनस एक्सपेक्टेशन ऑफ एक्स का होल स्क्वायर. म्यू इज एक्सपेक्टेशन ऑफ एक्स. Then I have told you the sigma xy, that is the covariance term. Covariance term sigma xy, that is the expectation of x minus mu x and y minus mu y. ठीक है. So this is sigma xy and इसका बहुत सारे इंटरप्रिटेशन में क्लास में बताया था कि this gives you the two random variables, the measure of nature of association between them. Okay, कितने एसोसिएटेड है तो उसके बारे में बताता है. Then it describes the linear relationship between the two random variable. तो टू रैंडम हाउ दे आर लिनियरली रिलेटेड टू ईच अदर उसके बारे में बताता है। ठीक है, तो ये इंटरप्रिटेशन पढ़ लेना, मे भी शॉर्ट क्वेश्चन में आ सकता है ये सब। ठीक है, देन सिग्मा एक्स वाई का एक सिंप्लीफाइड वर्जन था, दैट इज एक्सपेक्टेशन ऑफ एक्स वाई माइनस म्यू एक्स म्यू वाई। ठीक है, यस, देन कोरिलेशन rho xy that is equals to sigma xy divided by sigma x sigma y। ठीक है, मीन और वेरिएंस के लीनियर कॉम्बिनेशंस था। ठीक है, उसके बाद देन इंडिपेंडेंट होता है, तो एक प्रॉपर्टी था हमारे पास, इंडिपेंडेंट होने से एक्सपेक्टेशन ऑफ एक्स वाई दैट बिकम्स एक्सपेक्टेशन ऑफ एक्स expectation of I if x and y are independent। ठीक है, x and y are independent, then this happens। ठीक है, तो इसके चलते हमारा कोवेरिएंस भी सिग्मा एक्स वाई इक्वल टू 0 हो जाता है इफ इंडिपेंडेंट, and rho is also becomes equals to 0। So we say that, तो इसका इंटरप्रिटेशन क्या था कि if independent then this is equals to 0, but if this is not equals to this equals to 0, मतलब कि if sigma x equals to 0, we cannot say that they are independent or not, but we can say that there is no linear relationship between the two random variables, but that doesn't mean that they are independent actually। ठीक है, there may be quadratic or cubic whatever may be the relation in between them। ठीक है, तो ये चीज से भी ध्यान में रखना। देन ये कंप्लीट हो गया। नेक्स्ट वन इज द चैप्टर नंबर 5। तो वहां पे हम लोग क्या क्या डिस्ट्रीब्यूशन के बारे में देखे थे। फर्स्ट देखे थे बर्नौली। ठीक है, सो चैप्टर 5 discrete body distribution। discrete body distribution तो क्या था, फर्स्ट बर्नौली था, then next one is the binomial। ठीक है, बर्नौली क्या था, it has only two outcomes, either 0 or 1। ठीक है, और इसके पैरामीटर्स है, यहाँ पे लिखता हूँ पैरामीटर्स is only p and PMF that is equals to क्या है, but x equals to x is p to the power x into 1 minus p to the power 1 minus x for x equals to 0 and 1, then 0 elsewhere। ठीक है, बाइनोमियल में क्या है कि वही सेम ट्रू और फॉल्स या सक्सेस और फेल्यूर, but the parameters are n and p, there are two parameter, notation is this one, b and p। okay, then f of x is binomial का, so ncx p to the power x q to the power n minus x। okay, and 0 also। so ये हो गया बाइनोमियल का PMF। ठीक है, नेक्स्ट इज मल्टीनोमियल डिस्ट्रीब्यूशन। मल्टीनोमियल डिस्ट्रीब्यूशन, ठीक है, मल्टीनोमियल डिस्ट्रीब्यूशन में देख सकते हो, मल्टीनोमियल डिस्ट्रीब्यूशन में जो तुम्हारा जो यहाँ पे 0 और 1 था, वहां पे ऐसे करके कितने, मतलब कि I1 I2 ऐसे करके n नंबर ऑफ पॉसिबिलिटीज हो गई वहां पे। तो ये सिलेक्टिंग ईच वन उसका प्रोबेबिलिटी हम लोग कैलकुलेट कर रहे थे वहां पे, ठीक है। देन हाइपोजियोमेट्रिक डिस्ट्रीब्यूशन उसके बाद था, हाइपोजियोमेट्रिक एंड देन हाइपोजियोमेट्रिक में क्या था, एन नंबर ऑफ एलिमेंट्स था, उनमें से नंबर ऑफ सॉरी के नंबर ऑफ एलिमेंट फ्रॉम द k number of elements and n minus k number of elements from the category 1, ये category 2, n elements are chosen, so उनमें से कितने category A में है, कितने category B में है, ठीक है। तो इस तरीके से सॉल्व करना, ओके। Then negative binomial, negative binomial, negative binomial, नेगेटिव बाइनोमियल, नेगेटिव एंड बाइनोमियल के बीच में क्या डिफरेंस क्या था कि यहाँ पे आउट ऑफ 10 कोई भी 5 में से होगा, कोई भी 5 मतलब कि सक्सेस हो सकता है, बट नेगेटिव बाइनोमियल क्या है कि 10th one that must be the 5th success, 10th one that must be the 5th success. इस मतलब दिस इज द बेसिक डिफरेंस बिटवीन द नेगेटिव बाइनोमियल एंड द बाइनोमियल डिस्ट्रीब्यूशन, ठीक है। देन ज्योमेट्रिक डिस्ट्रीब्यूशन बताया था, देन पॉइजन, एक है जियोमेट्रिक, देन पॉइजन। पॉइजन के बहुत सारे प्रॉपर्टीज भी दिए थे, तो मैं भी देख सकते हो। तो ज्योमेट्रिक डिस्ट्रीब्यूशन वन ऑफ द स्पेशल काइंड ऑफ नेगेटिव डिस्ट्रीब्यूशन, जहाँ पे कि व्हाट इज द प्रोबेबिलिटी दैट आई विल गेट द 10 ट्रायल्स आई विल गेट द फर्स्ट सक्सेस। ज्योमेट्रिक हर टाइम फर्स्ट सक्सेस के बारे में बताता है, और पॉइजन क्या है, नंबर ऑफ आउटकम्स के ऊपर डिपेंड करता है। इसका एक पैरामीटर है, इसका पैरामीटर लैम्ब्डा टी, जो कि एवरेज मतलब कि ऑन एन एवरेज कितना टाइम जा रहा है, ठीक है। नंबर ऑफ आउटकम्स है, वैसे करके तो हर किसी का जो पीएमएफ है वो देख लेना। तो पॉइजन का क्या पीएमएफ है, एफ ऑफ एक्स ई टू द पावर माइनस लैम्ब्डा लैम्ब्डा
लैम्ब्डा टी टू द पावर एक्स बाय एक्स फैक्टोरियल।
हाँ, तो ये हो गया पॉइजन डिस्ट्रीब्यूशन का। तो ज्योमेट्रिक डिस्ट्रीब्यूशन का क्या है, पी एक ही सक्सेस आएगा, क्यू टू द पावर एन माइनस 1 ज्योमेट्रिक का। नेगेटिव का क्या था, एन माइनस सॉरी के सक्सेसेस है ना, और एन नंबर ऑफ ट्रायल्स, दीज आर एन नंबर एन माइनस 1, चूज के माइनस 1 e to the power k q to the power n minus k। सो रैपिडली मैं सारा चीज जस्ट ओवरऑली बता दिया कि क्या क्या चीजें हैं। यदि कोई स्पेसिफिक डाउट है तो पूछ सकते हो, ओके। तो टाइम ज्यादा नहीं है, देन यदि कुछ डाउट है तो पूछ सकते हो। ओके देन ठीक है, तो ऑल द बेस्ट सबको, सबको अच्छे से
थैंक यू
एग्जाम
सर।
देना, ठीक है। तो यदि किसी को स्पेसिफिक डाउट होगा तो मैसेज कर देना, ठीक है। ये पॉसिबल
Sure,
टाइम,
sir.
यदि टाइम मिलता है तो मैं सॉल्व करके दे दूंगा, ठीक है। मोस्टली दोस्त लोग हैं बहुत सारे, तुम लोग पूछ लेना, यदि कुछ ज्यादा भी डाउट होगा तो मुझे पूछ लेना, ठीक है। ये तो परसों ही एग्जाम है ना?
यस सर, परसों है।
हाँ, तो आज यदि डाउट नहीं पूछे तो कल तो डाउट होना नहीं चाहिए, आई थिंक।
यस सर।
ठीक है, परसों एग्जाम है तो और क्या ही दिन है, टाइम कहाँ है। चलो ठीक है।
थैंक यू सर।
ओके ओके, ठीक है, ऑल द बेस्ट सबको।
थैंक यू सर।
थैंक यू।
Okay, good morning, students. Am I audible to you all?
Yes, sir, audible.
Okay.
Excuse me, sir.
Yes, yes.
Sir, I have a doubt regarding like number of questions. So, sir, how many number of questions will be there in the midsem?
Depending on the marks, I guess.
I guess 30 questions or like what, sir?
No, we have actually submitted the questions. We do not know the format yet. So once you give
Okay.
the exams, then we'll know what the examination section has said the questions. Okay.
Yeah, okay, sir.
So it might be single mark questions or 2 mark questions, like you had your previous online exam. Is there any notice regarding the change of exams, or it is still happening on 17th?
No, sir, there is no notice. So it most probably it will happen day after tomorrow only.
Okay, okay. Okay. So yes, we have already completed the last topic in your course, that is quicksort. Okay. And for quicksort, we will now go to the, yes, any doubts in quicksort in the last class? Anyone who could not understand the partition procedure or this quicksort procedure? Yes, why are all
Sir, partition
demanding
procedure.
one partition? I'll tell again. Okay. So why all are saying 1 day more? Today is the last date of submitting the assignment. Genuinely, why do you need 1 day more? And I think more than 10 days you have got. Submit, all of you, if you have done your assignments, submit it today itself, okay? Exceptional cases who are having problems, we will see. But most of you should submit your assignments by today. Okay?
Sir, today at 12, right? Like 12 a.m. is the last date, like timings, right?
11:59:59.
Oh, sure, sir. Okay, sir.
Yes. What is the doubt in partition procedure? Manas?
Sir, that example, second example, sir.
Which one?
378521. No, sir, second
3-7? Yes, what is the example?
37.
The question that I gave you. This one.
Yes, sir, that one.
This 3-7, 13, 19, 9, na?
No, sir, not that one.
Then
3785
3785
21954
21954.
9554.
Yes. What is the problem in this question? Try to find the partition. This will be my pivot element. Okay. Yes. At the first point, I is pointing to this location. My J is pointing to this location. P is pointing to the first location. Okay. So first thing that will be compared is A of J less than equal to X. This is my X. Okay. So if the first thing is compared, in the first step, is 3 less than 4? Is 3
Yes.
less than 4? Yes or no? So two things will happen. I is equal to I plus 1. Okay. So now I will also point to this location. Okay. In that situation, now J is pointing to the first location. I is pointing to the first location. Okay. So in that case, now 3 will remain in its place and the next array will be something like this. 3, 7, 8, 5, 2, 1, 9, 5, 4. Okay. Now J will move forward to this location. Okay. Now 7 is compared with 4. The 7 is compared with 4. It is not smaller, so now it will move on to the next position. 8 is compared with 4, nothing will change. Okay. 5 is greater than 4, again nothing will change. Okay. In the next scenario now, this is 2 now. Okay. When this is 2, at that point, we will now replace the value of this 7 with this 2. So now it will become 3, 2, 8, 5, 7, 1, 9, 5, 4. Okay. Now after this 2, now J will point to this location. When J is pointing to this location, now the value is 1. Okay. When the value is 1, now if you see 1 is smaller than 4. So there will be definitely an exchange. So this position will be exchanged with 1. So it will become 3, 2, 1. Then it is 5, 7, 8, 9, 5, 4. Okay. Now 8 will be compared with 4. Sorry. 9 will be compared with 4. Okay. No changes. 5 will be compared with 4. No changes. After this, if you see, the value of I is pointing to this location. Now I plus 1 is this location. So exchange this value with this value. So it will become 3, 2, 1. Then it is 4, 7, 8, 9 and 5. Yes, is it clear now? This position will be returned.
Sir, but in page 11 it is different, sir.
Different?
Yes, sir. In page 11. Yes, sir.
Why different? How different?
Sir, that is 3, 1, 2, 4. 3, 2, 1.
Yes, what they have done, let us see. Why it is wrong. Yes. Now 7 will be exchanged with 7 will not be exchanged. Okay. 8 will not be exchanged. 3 will be exchanged with itself. Okay. Then it is 5. 5 will not be exchanged. 2. 2 will be exchanged. So they have done a mistake. Okay. This is wrong. This will not be the output. Okay.
Okay, sir.
Try to solve this one. Okay. Try to solve this question. That is why I am saying try to solve yourself. Even if the slides are wrong, then you will know it. Okay. Once you solve it. Solve this question. Let us solve this question so that our answer will be more clear. Okay. This is a PS class. So you have 2 hours. So try solving this question. I will give you the answers after 20 minutes. Okay. You have 20 minutes to solve this question. Apply partition procedure on this. Okay. I will change the slides and I will then send you. Okay. Apply the partition procedure on this algorithm. On this array. Okay. Do it on a copy or do it on the screen so that you can share your screen. Okay. I will ask anyone to share the screen. So try doing it. Once you do it, then you will understand today's class. If you don't do it, I can guarantee you will not understand today's class. Okay. So try to do the partition, apply the partition procedure on this question. Yes, am I clear? Am I
Yes.
audible to you?
Yes.
Yes, anyone who has completed.
Yes, sir.
Yes, you can share your screen.
Sir, actually, I want to ask that we have to write in copy, right? Or we have to code it?
कॉपी में लिखो, फोटो उठा के शेयर कर दो.
अच्छा ठीक है सर, फोटो उठा के करता हूँ सर. फोटो नहीं लिया सर. ठीक.
फोटो उठा के शेयर करो.
ओके सर.
करो, शेयर करो.
हाँ सर, कर रहा हूँ. सर स्क्रीन विजिबल है?
यस.
ओके सर.
जूम करो थोड़ा उसको. क्या किया? ओके. इसमें फर्स्ट थोड़ा जूम करो उसको. यस. 919 in the first step. Explain, you can explain your answer.
हेलो. यस सर.
Yes, yes, sir. क्या किया वो बोलो. Yes, the given question is 13, 9, 19, 9, 5, 12, 8, 7, 4, 21, 2, 6 and 11. In the first step, the array will become 9, 19, 13. Then it will become 13, then 5, then 12, then 8, 7, 4, 21, 2, 6, then 11. Okay. The first step, anyone has got any other answers? In the first step, anyone has got any other answer? I think
yes, sir.
yes, what is the difference you have got?
So fourth step पे the like यहाँ पे change नहीं हो रहा sir.
Fourth step में change होगा.
So first step पे नहीं change हो रहा sir, third पे जाके change हो रहा.
नहीं, first step itself it will change ना.
How sir? ये कैसे होगा? थोड़ा explain कर देंगे sir.
Yes, let us do it. Let us do this so that we can understand where we can. Yes, just tell me the question. (13, 19, 9). Then there will be 5, 12, 8, 7, 4, 21, 2, 6, 11. Okay. So if you see in the first step, in the first iteration itself, it will not change. My screen is not visible. Let me just share my.
हेलो, am I audible? सर
Yes, yes.
अरे सर वो मेरा नेट पता नहीं सर सडनली वो हो गया सर.
हाँ ठीक, मैं शेयर कर रहा हूँ, इसको सॉल्व करेंगे. Yes. So if I saw, is my screen visible now? Okay.
Yes.
My J is pointing to this location. Okay. My X is pointing to this location. This is P. This is I. Okay. So in the first step itself, no exchange will happen. Okay. Why? Because this is greater, so we do not need to exchange. The J pointer will come to 19. Okay. In the second step now, this 19, let me just write it. 13, 19, 9, 5, 12, 8, 7, 4, 21, 2, 6, 11. Okay. So now, in the second step, again no exchange will happen. Why? Because this 19 is bigger than 11. Okay. So it will remain 13, 19, 9, 5, 12, 8, 7, 4, 21, 2, 6, 11. Okay. Now still I is pointing to this location. J is now pointing here. If you see, in this step, 9 is lesser than 11. Okay. Once 9 is lesser than 11, just increment the value of I. Okay. And now exchange the value of I with the third element. So it will become something like 9, then it will be 19, then it will be 13, then 5, then 12, then 8, then 7, 4, 21, 2, 6, 11. Okay. Now we come to this step. Next step, 5 is smaller. A of J is smaller than X. So I value will be incremented and one exchange will happen. So it will become 9, 5, 13, 19, 12, 8, 7, 4, 21, 2, 6, 11. Okay. Now J value is pointing to this location. Okay. 12 is bigger than 11, so I value will not be incremented. Okay. Now, just give me a second. Yes. Now in the next step, it will be this 12 will not be replaced. Then it will be at the point 8. When, let me write the 12 one also. 5, 13, 19, 12. Okay. After that, 8, 7, 4, 21, 2, 6, 11. Okay. Next, when this 8 comes, it will be swapped. This 8, because 8 is smaller than 11, and 8 will be swapped with which value? 13. So now we have 9, 5, 8. Okay. Then we have 19, 12, 13, 7, 4, 21, 2, 6, 11. Okay. I is now pointing to this location. Okay. So here now I have another 7. When this 7 is encountered, again I value will be incremented. So it will become 9, 5, 8, 7, then 19, then 12, then 13. Sorry. Yes. This 19 will be exchanged with now 7. Okay. So it will become 9, 5, 8, then it will become 7, then 12, 13, 19, 4, 21, 2, 6, 11. Okay. Now, J value is incremented to 4. When j value is incremented to 4, 4 is less than 11, so we have to perform an exchange. This 4 will be exchanged with 12 now. Okay, now it becomes 9, 5, 8, 7, then this one becomes 4, 13, 19, 12, 21, 2, 6, 11. Okay. Next, now the I value is incremented, j value is incremented to 21. 21 is greater, so nothing will happen. Now we have 2. When we have the point 2, 2 is less than 11, so there should be one exchange. So now this 2 will be exchanged with 13. So we have 9, 5, 8, 7, 4, then we have 2, then 19, 12, 21, 13, 6, 11. Okay, now j is pointing to 6. When j is pointing to 6, 6 is less than 11. One more swap will be there. 19 will be exchanged with 6. So we have 9, 5, 8, 7, 4, 2, 6, 12, 21. Then there is 13. Then there is 11. Okay. Now my eye is pointing to
Sir,
this
19.
location. Where is 19? This one is 19.
After 13, sir.
Then 1911.
After 13, 13, 19, 11. Yes. So which position is our eye pointing to now? Eye is probably
to-
pointing to this position. No. That is I plus 1.
Yes, sir. 6.
I. X of R with X of I plus 1. Yes or no? So I have
Yes, sir.
9, 5, 8, 7, 4, 2, 6, 11, 12, 21, 13, 19. Then there will be 12, 12. I just another question. Yes, this 12 will be exchanged with 11. Okay, so now we have 9, 5, 8, 7, 4, 2, 6, 11, then 21, then 13, then 19, then 12. Yes, this is the final one anyone has got.
Yes, sir.
Yes,
Yes,
this
sir.
is the final thing that you will get. Now, one thing to observe here. Where my eye is ending, still my eye is ending here. Yes or no?
Yes, sir.
Yes or no? In the first step, my eye is pointing to this location. Yes. In the next iteration, eye is pointing to this location. Okay. In the third iteration, now eye is pointing to this location. Okay. So if you observe, now eye is pointing to this location. Okay. So everywhere, not drawing the lower steps. Okay. So yes, if you see, now I was pointing to this location, now I is pointing to this location, all these values. Okay. Are they always smaller than the pivot value? The value, am I audible to you all?
Yes, sir.
Okay. So now I am saying there is a value from P to I. Okay. I am saying in every iteration, the subset or the subarray A P to I is always less than X. Is it true? Look at your quick runs, dry runs that you have done. Wherever the value of I will go from P to I value is always lesser than. If you see, I have marked the subarray in blue. All the values are lesser than 11. Here, the I value was until this. So all the values, are they lesser than 11? The I value was here in the third iteration or the previous iteration. So the I value is the set P to I is always less than the pivot value. Here also, P to I, it is always less than the pivot value. Here also, P to I, is it less than the pivot value? Yes or no? Can you observe it?
Yes, sir.
So we are saying this value will be always less than equal to X. Okay. And next we are saying in every iteration, the sub array, okay, A, sorry, A, I plus 1 up to J minus 1. Okay, this value will always be greater than equal to X in every iteration. Yes, can you observe that? As you see here, J is pointing to this location. Okay, so now I am saying I plus 1 means from here to here until this is exchanged. Okay, from here to it is J is pointing to this location, so J minus 1 will point until this location. Okay, so can you see? Yes, this is my I plus 1 to J minus 1. This is my I plus 1 to J minus 1. Now this is my I plus 1 to, this is my J minus 1. Yes, can you see all the values there? This is until this. Okay. Yes, all the values in the in the set I plus 1 to J minus 1, it is always greater than the pivot element. If you see, the J value is until this. So, J value is now this. So, from I plus 1 to J minus 1, all the values are greater than the pivot element. Yes or no? Look at your dry run. If you look at your dry run, in every iteration you write the value of P, I and J, you will see that all the elements from I plus 1 until J minus 1, they will be always greater than the pivot element. Okay. Now, the elements from J minus 1 until R minus 1, okay, nothing is defined. Are they greater or lesser? Nothing is defined. And the last element, of course, is the pivot element. So at every point or every iteration, the array is divided into 4 regions. Okay, what are the regions that the array is divided to in each iteration? Okay, the first section is from P, is the subarray from P until I. This subarray says all the elements are less than X. Okay, the second region that is divided into is I plus 1 until you have J minus 1. This will be always greater than equal to X. Okay, X is the pivot element. Now the third region that will be formed is from J to R minus 1. Nothing can be said about it. Okay, then the last region is A of R, which is equal to X, the pivot element. Can you observe these 4 regions in every iteration that you have done? Just look at your copy and tell me, is in every iteration, these four regions are present.
Yes,
In
sir.
every iteration in your dry run, are these four regions present? From P to I, it is one region. From I plus 1 to j minus 1, it is another region. The third region is from j to r minus 1. And the last region is the pivot element, which is x. So basically, in every iteration, these four regions are being maintained. Yes or no?
Yes, sir.
Yes. If these four regions are being maintained, okay, something is not changing inside the loop. That is known as its loop invariant. Now I can say that if for the initialization step, I can prove that these four regions exist. Now for the maintenance step, I can show that these four regions exist. Again, in the termination step, okay, I can show that these four regions exist. If I can show the three steps of a loop invariant correctness, then we can show that quicksort is a correct algorithm. Okay. So if you want to prove the correctness of quicksort using the loop invariant concept, then you have to show that something inside the loop always remains constant. Now, from our dry run, we have found out that during the execution or during the iteration, these four regions always remain constant. So whatever might be the situation, these four regions will always be present. And those four regions are our loop invariant. Now, we are going to prove that these four regions will always exist in the three steps. That is your termination, maintenance, and initialization. Okay. Now, we are saying the first thing is the initialization case. Okay. In the initialization case, if we see, initialization is always before the start of the loop. Okay. So before the start of the loop, you are going to see if the four regions are being maintained or not. Okay. So now we are saying before the start of the loop, I will be pointing to this location. J is now pointing to the first location. Okay. Now we are saying P is pointing to this location again. Okay. In the set A, our first region is from A, P to I. Is there any element before the start of the loop? Because I value is now 0, P value is 1. Between 1 to 0, do you have any element? Can there be any element possible? Yes, one element will be there. Okay, but if one element is present here, is it already sorted?
Yes, sir.
Trivially, it is sorted. Okay. Again, let us look at the second region, which is smaller, which is greater. You don't have anything now because there is only one element. Now, between A, I plus 1 to j minus 1. So this is now I plus 1 is now 0 plus 1 and j minus 1 is now 1 minus 1. So between 0 and 1. Again that one element is there. So this is also trivially satisfying the situation. Okay. Of course, from I plus 1 until the last, before the last but the one element, we cannot say anything about this. Is it defined? No. Of course, the last element is the pivot element. So, before the start of the loop, are the four regions being maintained?
Yes, sir.
Is the initialization step understood?
Yes, sir.
Now, if you understand the initialization step, let's go to the maintenance step. In the maintenance step, now I am saying, now I am saying there are four regions before the start of any iteration. Okay, nth iteration. Okay, let us assume that before the nth iteration, this much is there. So all these elements, they are less than x. So this point must be my I, because we are saying p to I will be less than I plus 1 until the j minus 1. All those elements, let us assume before any iteration. Okay, these are greater than x. Now we also assume there is a region which is not defined. This region, we cannot say any particular relationship with x. Okay, and in the last place, there is the pivot element x. So before the start of any iteration, this is the condition of the array, because we are assuming four regions are there, and we have to show that if an iteration occurs, then there will be no change in this status. Okay, if you can show that the four regions are maintained even after an iteration, then you can show that the maintenance step is over. Okay, so let me just take the example. Now this is the array before the start of the iteration. In the iteration, two possibilities can be there. Okay, one possibility is a of j is less than equal to x. What is the other possibility? Yes, these two things can happen. Yes or no? Am I audible to you all? Inside the for loop, inside the loop, once you enter the loop, there can be two possibilities. Na? Either a of j will be less than or a of j will be greater than. If this is my j now, let case 1 occur. Let case 1 occur. Okay, let us assume case 1 is a of j is greater than equal to x. When this a of j will be greater than equal to x, what do you think will happen in the algorithm? What do you think will happen in the algorithm if this a of j is greater than x? Yes, come on, answer. You can answer it. अरे a of j अगर बड़ा हो रहा है x से, तो what is the algorithm doing?
j plus plus.
Exactly. Only the j value is being increased. So once in this case 1 is encountered, we will just increase the j value to this, right? So now our j minus 1 will now include this. So now this area will also become, green. Why? We have just increased the j value when a greater element is found. So if the case 1 occurs, are the four regions being maintained? This region is shrinking, but this region is increasing in this direction only. Na? Now suppose case 2 occurs. When case 2 occurs, A of j is less than equal to x. So two things will happen. Okay. I is equal to I plus 1. So now, if there... Yes, am I audible now? अभी आ रहा है आवाज?
No, sir.
अरे तुम्हारा प्रॉब्लम होगा. Is am I audible to everyone?
Yes, sir, you are audible.
Yes, मानव तुम्हारा नेटवर्क प्रॉब्लम होगा, थोड़ा चेक करो. Okay. Let me know if others are also not able to hear me, then let me know. Okay. So now in the case 2, two things will happen. If a smaller element is found here, let me just redraw it. So this is my blue zone, smaller element. There is a green zone, the greater element. Now Q is pointing to this location. There is a black zone, which is undefined. This is also undefined. Okay. And there is the final element X. So when case 2 occurs, what we are going to do? We are increasing the value of I. Okay. So now I will just increase the value of I. So this blue zone will increase. And I will exchange A of I with A of j. So this X, it will come here now because it was smaller. Okay. And this larger element will now come here. Okay. So if you see, even if the second case occurs, these 4 regions will be maintained. The first region will just increase and the second region will just shrink. Okay. This green zone will also be present. Okay. In the third case, see, this will be exchanged with this. So the smaller element will come here and the larger element will come here. So if you see, again the sections are being maintained. So even if you take case 1 or you take case 2, is the loop invariant always maintained? Even if you take case 1 or you take case 2, the loop invariant will always be maintained. Yes or no?
Yes, sir.
Anyone who could not understand? Anyone who could not understand this proof? Yes, yes.
सर एक बार एरिया के हिसाब से बता दीजिए तो.
एरिया के हिसाब से मतलब
कौन सा एरिया श्रिंक हुआ और कौन सा एक्सपैंड हुआ?
अरे श्रिंक कुछ नहीं होगा. वी आर एक्सचेंजिंग सो द एरिया विल रिमेन सेम.
सर रीजन
सिर्फ वो ब्लैक एरिया होगा.
ग्रीन एक्सपैंड
undefined part, yes, green will expand in the case 1 and this will shrink because undefined को at the end everything will be defined.
Sir,
when we are getting the output, let me show you. इसमें अभी तक blue है. Okay. Then there is a green part which is greater. When case 1 occurs, so in that case ये element बड़ा है than our X. So I will just do a J++. So my green area will increase and my black area will decrease, which is my undefined area. ये भी undefined था ना, लेकिन अब हमको पता चल गया कि ये बड़ा है. So in the case 2, similarly things will happen. In the case 2, the blue area will increase. Okay, why? Because if a smaller element is found here, then that should be brought here. So if a smaller element is found, now my I was until this, the first thing I will do is I is equal to I plus 1. So my I will now point to this location. Okay. And I will bring this element here and take this element here. Okay. So the green
Yes.
area will remain same.
Constant.
Okay. And what is decreasing? The undefined area is decreasing actually. क्योंकि हमको पता चला ये अनडिफाइंड बड़ा है इसलिए हमने जे को बढ़ा दिया. अभी हमको पता चला ये अनडिफाइंड छोटा है इसलिए हमने उसको एक्सचेंज कर दिया और बड़ा वाला एलिमेंट हम यहाँ ले आए. There are two cases ना. Yes,
Yes.
is it clear now? Is it clear now?
Yes, sir.
The person who had doubt. Yes, this is all about the last lecture, which is the performance and correctness of the partition algorithm. So if you see, initially there is a region which is less than x. There is a region which is always greater than x. This is unrestricted or undefined, and the last position is always the pivot element. Okay. Now, if this is case 1, in the case 1, we are just, you can see, we are increasing the value of the green part. This was not there. Now this has been increased because a greater element was found. Okay. And if you see the second part, then here we will increase the value of I. Now this was green, now this became blue. This is the value of I is increased and then the element is exchanged. So again, these 4 regions will remain as they are. Okay. So even if you go through the iteration, the 2 cases will occur. In both the cases, the loop invariant survives. It also survived the initialization case. Okay. Now let us see what will be the termination case. If you go to the algorithm, okay. If you go to the algorithm, when the algorithm will terminate, just look at the algorithm and tell me when the algorithm will terminate.
It's come to R minus 1.
J is equal to R minus 1. Okay. Now put the value of J is equal to R minus 1 in your subarray. Put the value of J is equal to R minus 1 in your loop invariant. The loop invariant saying A of P to R, then, P to I. Then the second one is A is equal to P to J minus 1. The third one is A is equal to this J to R minus 1. Okay. So when J is equal to R minus 1, is the undefined region gone? When J is equal to R minus 1, will the undefined region shrink to 0 elements? Yes or no? At the place of J, put R minus 1. R minus 1 से R minus 1 कितने एलिमेंट्स होते हैं? 1 element will be there. So that is the last element before the pivot element. Okay. Now we will exchange this element with its proper position and bring the last element back. Okay. So this in turn will produce an array where until the value of I we had all smaller elements. So after I, that is in the I plus 1 element, I put the value X. And after that, all the elements are greater. Here, all these elements are smaller. So this will terminate our algorithm And if you see, the expected output that we wanted is that the pivot should be placed in its correct position and all the elements to the left of pivot are smaller and all the elements to the right of pivot are greater. So this brings us to the termination. Okay. And we can say that since the loop invariant survives the initialization, maintenance, and termination, quicksort is a correct algorithm. Yes. Is it clear why quicksort is a correct algorithm?
Termination one.
Uh-huh.
Termination parts are one.
When the algorithm will terminate?
R minus one.
R minus 1. What is the third condition? That is the undefined condition. What is the undefined? इस part का क्या value है?
J to R minus one.
J to R minus 1. अभी J के जगह पे क्या डाल सकते हैं जब algorithm terminate कर रहा है?
R
और
minus
J के जगह पे क्या डाल सकते हैं? R minus 1 डाल सकते हैं. तो R minus 1 से R minus 1 कितने A of 1 to 1 कितने एलिमेंट्स होंगे?
one element.
1 एलिमेंट. ओके. सो जब एक एलिमेंट उसमें रहा, then that means we have reached to the end of the array. This portion is now totally swing. अब ये J यहाँ पे आ गया है. Yes or no? J is equal to R minus 1 मतलब क्या? J is pointing to this location now. अगर J is pointing to this location, तो ये सारे एलिमेंट्स या तो केस 1 में गए होंगे या केस 2 में गए होंगे.
Yes, sir.
तो मतलब ये रीजन श्रिंक हो गया पूरा. तो आइदर ये एलिमेंट यहाँ गए होंगे और ये एलिमेंट यहाँ गए होंगे. दिस मीन्स एट द एंड आई विल हैव, और लास्ट स्टेप भी देखो, लास्ट स्टेप क्या बोल रहा है? i+1 तक मैं आऊंगा और i+1 के जगह मैं अपने x को रखूंगा. आफ्टर दैट all the elements that are present will be greater than x. All these elements will be lesser than x. So this brings us to the termination step. Is it clear now?
Yes, sir.
Okay. Yes. So in this way, we can say that the algorithm for quicksort is actually a correct algorithm. Okay. The worst case algo occurs when the array is completely skewed. Okay. So if I take 9 elements in one side, 1 element in the other side, that can happen depending on the value of q, right? All these will be one half, all these will be the other half. Yes or no? This is also the average case. This case will occur in the average case also. In the average case, this is the best case. In the best case, the size of the pattern will be n by 2 and n by 2. The best case. Okay. And the average case for quicksort, it will occur when the, 9 and 1 division will produce the 1 on one side, 1 element, and 9 elements on the other side. Okay. Again, this division, 1 element will be on one side, 9 elements will be on the other side. So the equation that you will get is Tn is equal to T of 9n by 10 plus T of n by 10. 9 parts एक साइड में, एक पार्ट दूसरे साइड में. This will be my average case. And my worst case will be if n elements are on one side, 0 element is on the other side. Okay. And my best case will occur when n by 2 elements are on the left side, n by 2 elements are on the right side. Okay. Average will occur when 9 elements are on one side, 1 element is on the other side. Yes? Am I audible to you?
Yes, sir.
Audible to you all? Yes. Now we come to something called as a randomized quicksort. The only difference here is we are randomly going to select a pivot element. Okay. In our example, until now, we were selecting the last element as the pivot element. But here, we can just make a little change to the algorithm and we can get the pivot element by using a random function. So this will reduce the worst case behavior to average case. Why? Because if in a question, if you are given like this, that all the elements are like 9, 7, 6, 5, 1. Okay. So in this case, all the 4 will be divided into one side and this side has 0 elements, right? Pivot will not be considered. Okay. So in this case, this can be reduced if I take 9, 7, 6, 5 and 1. So randomly, the random algorithm might select this as the pivot element, or it might select this as the pivot element. So there will be 3 elements and there might be 1 element. So this will become the average case. But if I have an array like this, 9, 8, 7, 5, 9, 8, 7, 5. If we select the last element as the pivot, then this array will be divided into 2 halves. Okay. In one half, there will be only 0 elements, and in the other half, there will be 9, 8, 7, 5. Okay. Whatever the combination will come. Now, if I take the randomized quicksort, in the randomized quicksort, it might so happen that this might be selected as the pivot element instead of this element. Okay. So definitely, if 7 is selected as the pivot element, then 5, 1, 7, 8, 9 will be there. So this will become one set, this will become the other set. So by using the randomized quicksort, we can convert the worst case to average case. Yes, is this clear? Any doubts about the randomized quicksort? This brings us to the end of the quicksort algorithm. Okay. We have completed the quicksort algorithm, its correctness and its best case, worst case, and we have also seen what is the use of randomized quicksort and how randomized quicksort is better than the normal sort algorithm. Okay. Yes. So this is the topic that we have left. This is basically a greedy algorithm and mostly a theoretical topic. Okay. So you just need to understand what is the meaning of clustering. Once you understand the meaning of clustering, then you can understand the greedy algorithm. This is a greedy algorithm. Okay. So what do we mean by clustering? Okay. So clustering arises when one has a collection of objects. Okay. Let us imagine a situation. Okay. Now, suppose this is the solar system. And we have another solar system like our solar system, which is present at a distance. Okay. So when I am looking at the sky through a telescope, I can see 2 major clusters. And how I can identify that this is cluster 1 and this is cluster 2? Because elements in a cluster lie close to one another. Now, if I say all the planets that make up the solar system one should lie within a radius of say 300 your light years. Okay. So if I say that the distance between them should not cross more than suppose X threshold. Okay. Then if you see between this point and this point, that is the point in one cluster and another point in another cluster, the distance will be greater than the threshold X. Okay. So that is why we can identify from the Euclidean distance that this point does not belong to cluster 1. Okay. Because if I take two clusters, if you see their distance is less than X, the threshold. But the distance between one point in cluster 1 and another point in cluster 2 will obviously be greater than X. Yes or no? So by looking at the Euclidean distance X between point 1 and point 2, we can say they do not belong to the same cluster. Okay. So based on the Euclidean distance, now I can say, yes, they are not belonging to the same cluster. So now this concept can be used to a variety of things. Okay. Now I am saying all the .org website and all the .com website. Yes, all the .orgs will form one cluster. All the .coms will form one cluster. And we can identify that org is not same as the .com cluster because of certain parameters and certain distance. Okay. Here the Euclidean distance is the difference in the domain name. Let us say, if you have gone through your, somebody has Oppo or Vivo phones, then this feature is there in that for those phones. They are saying that if you suppose click 5 selfies, they will actually make selfie as a folder and add all those images to it and name it as selfie. Yes or no? Anyone has seen this feature? This is a type of clustering. How they are finding it? They are finding the Euclidean distance in terms of pixels. If the pixel of this photo is almost 90% same, then this is a failed selfie and this is also a failed selfie. So add everything to the selfie folder. Yes, this is a kind of clustering that we are talking about. Okay. So a lot of objects can be classified whenever we have a collection of objects. Okay. These collection of objects can be a set of photographs, a set of documents, a set of microorganisms. So if you see all the viruses, they will be present at one place. All the bacteria, they will be present at another place. All the fungi, they will be present at another place. So by looking at the distance between them, I can say this is cluster 1, this is cluster 2, this is cluster 3. Okay. Now, faced with such a situation, it is now natural to look for the measures of how similar or dissimilar two objects are. If they are similar, add it to the same cluster. If they are dissimilar, add it to different clusters. Okay. One common approach is to define a distance function. This distance function can be different. Okay. So if I say genetic engineering, then suppose this is my sequence of proteins. Okay. I can say this sequence and the other sequence. What is the difference? Yes, the difference in number of places. Now this will become my distance function. Photographs. Okay. Two photographs are matched. The number of pixels or similarity of pixels. This can become my distance function. So based on the type of data that you are given, you have to now define a distance function. Okay. And this distance function can give us the idea of if a element belongs to a cluster or not. Okay. Objects at a larger distance from one another are less similar to each other. Obviously, if I see all the bacteria are here, all the fungi are here. The distance between two fungi, it is less. The distance between a bacteria and a fungi, it is much more. So I can say that definitely these two are not similar organisms. They are different organisms. How could I say this? By looking at the distance function m. This distance function can have different meaning for different problems. Okay. It can mean the change in domain name. That is the distance function for your website. For genetic algorithm, change in the number of protein sequences. That is the similarity or that is the different distance function. Okay. So based on this concept, now this is the input that is given to us. Okay. Now starting at one point, you have to find the cluster while making sure that this cluster and this cluster are not intermixed. Okay. This is a separate cluster. This is definitely a separate cluster. Why? If you see the distance between the element in a cluster is much lesser than the distance between two different elements of two different clusters. Okay. So if you can define a distance function, based on that distance function, I can say start from this point. Okay. Go to the next point, which is at a distance less than equal to x. So if I come here, is the distance less than equal to x? No. So this point and this point will never be connected. Why? We will connect the points which lie within the distance function. Okay. Start from here. We'll go to the next closest point, next closest point, next closest point. Go on doing this until we have found k edges. Okay. So this k edges is known as k-means clustering. Now, if you remember, I was giving you a graph. I am saying, okay, we'll come to this. Before, let us go to what are the types of clustering. Okay. Yes, not only necessary that clusters will be present in spherical spheres. Okay. Clusters can be of any shape and size. Okay. If you see, there is a horizontal cluster here and we have a semicircular cluster here. Okay. Again, if you see, clusters can be present at very lesser distance. If you see, the distance between these two is almost same as distance between these two. So now it becomes even more difficult to define the distance function. So now the distance function here, it should be more precise. Okay. More precise means more accurate. Okay. Now you cannot say only based on the distance function that you will find the clusters correctly. Okay. You have to now look at multiple things before you can find these clusters. Okay. Clusters can also be given in a group without the distance. Here, the distance function will not work in terms of Euclidean distance. Now, you have to compare the properties between these two. Okay, because an apple is not equal to a pear, is not equal to a strawberry. So we have to make three different clusters now. So one will be the apple cluster based on the property of all the fruits that have the property of an apple, all the fruits which have the property of a pear, and all the fruits which have the property of strawberry. Okay, so now you have to apply a clustering algorithm here so that our cluster can be found out. Okay, so if we are given the problem of K clustering, then the types of clustering can be the hard clustering or soft clustering. Okay, where this is soft clustering. Data points belong to only one group. Only one group is there. You are asked to classify or you are asked to cluster. Okay. Now, if two groups are given, I will say this is a soft clustering. If only one Yes, soft clustering and hard clustering. Okay. After that, we have different types of clustering techniques. Based on the technique, we will say that there is partitioning clustering. Okay. You are given the data points like this. If I can say that I will draw a line that will partition cluster 1 and partition cluster 2, I call it as partition based clustering. Okay. Similarly, there is the concept of density based clustering. I can say if the density of this is different from the density of this, then this is cluster 1 and this is cluster 2. Okay. Then there is distributed model of clustering. There is hierarchical clustering and fuzzy logic based clustering. Okay. Based on fuzzy concepts, you will now try to differentiate two different clusters. Okay. Now this is partition based clustering. If you can draw a line between two clusters, then that is known as the partition based clustering. Again, we go to the concept of density based clustering. Based on the density of two different clusters, the density here is different from the density here. So we can say that definitely the division happens and this is cluster 1 while this is cluster 2. Okay. Distribution based clustering. So based on the type of distributions, now you can say that yes, there can be a Gaussian distribution, there can be random distribution, there can be pseudo-random distribution, Poisson's distribution. Based on all those distribution models, you will now come up with the clustering technique. Okay. Hierarchical clustering. The clusters will be formed in a hierarchy. So if you see, there is some hierarchy here, then it goes down, it goes down. Finally, the hierarchy is given in a proper manner. Okay. Now, given a distance function on objects, so you are given the, this is actually the K clustering problem. Okay. So given a distance function on objects, the clustering problem seeks to divide them into groups that intuitively objects within the same group are close and objects in different groups are far apart. So you have to now create a division or a classification such that objects in one group are close while objects in two different groups are far apart. but two objects in between a group, they are close. So if you can do this, then this problem is known as the K clustering problem. Okay. Starting from a vague set of goals, the field of clustering branches into a vast number of technically different approaches. A large number of use it has. Okay. Just now I showed you how the selfies can be organized into a selfies folder. Okay. How the web pages can be organized, how you can find different solar systems or planets that belong to a particular solar system, how you can differentiate photographs, how you can recommend more things to the customers. All those things are the use of clustering. Now, how can we design an algorithm for clustering? The algorithm for clustering, if you remember Kruskals, then this algorithm is similar to the Kruskals algorithm. What was happening in the Kruskals algorithm? You are starting from a point and then selecting the edge which was lightest. Between this edge and this edge, we were selecting the light edge and the vertex that had the light edge. So here also, we will go on doing the same thing, but in the Kruskals algorithm, we were doing it until all vertices are covered. Here, we will do it until K edges have been added. Once you add the K edges into a cluster, then at that point, the clustering algorithm will stop. Okay. So how do you start? We start by taking, suppose there are 5 viruses. These 5 viruses are present close and there are 4 bacteria. They are lying close. So every organism that we are going to represent will form the node of a graph. Okay. And we are going to connect 2 nodes or 2 vertices if they lie within a distance, suppose x. If they lie within a certain threshold distance x, or if they lie in generalized terms, if 2 points will be connected, if their distance is less than the distance function PIPJ. Okay, I will define any distance function and now I will say if this distance function is less than a given threshold, then I will connect these 2 edges. Okay. In this way, we are going to grow the graph until K edges have been added. Okay. So this is just the application of your Kruskals algorithm of doing a minimum spanning tree. These are 4 edges. Now these are 4 edges. Sorry, 4 vertices. Now we are going to start from here. Okay. Apply the Kruskals algorithm here. Connect the closest pair of points. Okay. From here, now I will find which is the closest pair of points. This is the closest pair of points. I will connect this. Next, from here, I will find the closest pair of points. Again, from here, I will find the closest pair of points. From here, now I will try to find the closest pair of points. So this will be the closest pair of points. But the distance is greater than the distance function or threshold. So this will not be added to the cluster and the algorithm will terminate here itself, giving us the minimum cluster of first elements. Then again we will apply Kruskals algorithm on any remaining vertices. So this is the remaining vertex. So from here we'll find the closest point, from here the closest point, from here the closest point, from here the closest point and the closest point. Again, this will try to find the closest point from here. So this is the closest point, but this will not be added into the cluster because the distance will be more than the threshold. So now from our algorithm, we have found there are 2 clusters. Yes, is this clear or any doubts? Anyone who could not understand clustering? Yes. So with this, we come to the end of the course for your mid-sem, and I think I have, if you go through your lecture plan, I have almost covered all the lectures that are given in your lecture plan. Okay. So this topic was remaining, which is clustering, and now we have completed clustering also. Okay. Yes, I'll just share the link of the quiz so that you can all take the quiz. Yes, I have shared the link for today's quiz. You can take the quiz and let me know if it is accessible or not.
Excuse me, sir.
Yes.
There is a question in quiz. BFA circles a graph in linear time. So what exactly we have to write in that?
True or false? True or false?
Okay, sir.
Before you go to your exams, just go through the book once, okay, and try to go through the copy that you have made in the class, where we have solved all the examples. Okay, there is no problem that we have not solved for a particular course. Okay, go through the problems of BFS, DFS, shortest path, and all the Master's theorem problems that we have done. Go through the gritty algorithms. Then finally the divide and conquer examples that we have done. Quick sort, merge sort. These two are very important. Go for Huffman codes. There definitely you will get questions from Huffman codes. Okay. So yes, this way you should prepare. You should not only rely on the questions that I have given you. You should go for the book questions also, and also go for the Steven Skinner questions. Okay. Yes. So if your exam happens, then all the best for your exam, and please submit the assignment by today. Okay. No extension will be given to you, because then I have to again answer to the supervisor. Okay. So you have to submit it by today. Okay. Thank you for your time, and thank you for your patience. We'll meet in the next forthcoming classes. Okay. Thank you all.
Thank you, sir.
Good afternoon, all.
Good afternoon, ma'am.
Okay, so we have started the sequential circuit in the previous class. So is there any doubt of the sequential circuit? Hello? Hello? Am I audible? Am I audible?
Yes,
Hello?
ma'am.
So who can tell me, Ayush Patnaik, tell me, what do you mean by sequential circuit?
Ma'am, sequential circuit, ma'am, it requires the previous output.
No, you have to complete the answer, na? It is not complete answer. Who can tell complete answer? Hello? Who can tell complete answer? Ananya Anindita,
Yes, ma'am.
tell me, what do you mean by sequential circuit?
Ma'am, it is a type of circuit which is depend on the input and the output also.
What you are telling? Huh? This is a circuit which depend upon the input and output. Senawaz Alam.
Ma'am, means the order of the input depends only on the order of the input.
No. Senawaz Alam.
Yes, ma'am.
Sequential circuit.
It is a type of circuit which depend on memory. Sorry.
How it is differ from your combinational circuit? Combinational circuit, can you explain combinational circuit?
Ma'am, combinational circuit does not require memory.
Very good. And how you will explain combinational circuit?
Combinational circuit depend upon the only present input.
Combinational circuit depend or combinational circuit output?
Output, ma'am.
Okay. Combinational circuit output is depend upon present input only. So like this, you have to tell the answer. In sequential circuit, output does only
output.
Output not
Output
only
of the sequential circuit depend upon the output of the combinational circuit.
Not only depend upon the input, because in combinational output depend upon the input only, but in sequential it not only depend upon the input bottles the previous output, and that previous output is nothing but memory output. Have you understood?
Yes, ma'am.
Okay. Then there are how many types of circuit? 2 types. What are those? One is synchronous, another is the asynchronous sequential circuit. Okay. Then synchronous sequential circuit is a system whose behavior can be defined from the knowledge of its signal at discrete instant of time. That is the synchronous. And the behavior of an asynchronous sequential circuit depends upon the input signal at any instant of time and the order in which the input changes. So what is the meaning of this? That means synchronous sequential circuit means if all the behavior of all the component of the sequential circuit. So what are the components? One is combinational unit, another is the memory unit. If all are working at a particular time, so output is also getting at a particular time. Yes or no? Hello?
Yes, ma'am.
If the memory and combinational circuit, because total sequential circuit consists of a memory and a combinational circuit. If this memory and the combinational circuit are working at a particular time, then output we are getting at a particular time. So that one is known as synchronous. Okay. So for example, whenever you are watching the your TV program, just like suppose Dance India Dance or India's Best Dancer, anybody sing this one? Dance program, have you seen? Hello? Nobody is watching dance? No?
No, ma'am.
Okay. So only you are interested for coding? Because software engineers. You will be the future software engineers, so that's why you are interested in coding. Or what? Okay. So thing is that whenever one person is dancing, then we are not finding out the fault of that person. That person knows that what he is doing the problem or doing the mistake, he knows that one, she knows that one. But whenever the 2 or more persons are dancing, then you can easily find out the mistake. Yes or no? Hello? Hello?
Yes, ma'am.
Yes, ma'am.
Why? Because if there is no proper coordination between all the persons, then you can easily find out the mistake of whom. But if it is properly coordinated, then it is just look like one dance. Yes or no?
Yes, ma'am.
So that is the example of your synchronous sequential circuit. If all the components of that circuit are working at a particular discrete instant of time, at this particular instant of time, all are acting simultaneously, then your output will be occurring at that moment. So that is a synchronous. That means proper synchronization of all the component of the synchronous circuit. But asynchronous means suppose पहला डांस के बाद सेकंड डांस करेगा, सेकंड डांस के बाद थर्ड डांस करेगा. सो दैट मीन्स जब तक फर्स्ट वाला कंप्लीट नहीं होता तो सेकंड वाला करेगा. हेलो अरे सुनाई दे रहा है कि नहीं? तुम रिस्पॉन्ड नहीं कर रहे हो.
मैम फिर से बताइए.
सपोज देखो वो तो सिंक्रोनस समझ में आया.
यस मैम.
ओके. सेकेंड वाला मैं बोल रही हूँ कि सपोज वन टोटल कंप्लीट डांस इज डिपेंड अपॉन द 5 dances and after the completion of the first dancer then second dance start, then after the second third start, then after the third fourth start. So in a particular sequence. So here the thing is that the second dancer cannot dance unless until the first one completed.
Yes, ma'am.
Yes or no? And if the first person is taking much time, then the total process is also taking much time. Are you getting my
Yes,
point or
ma'am.
not? So पहले वाले का जो प्रॉब्लम होगा वही प्रॉब्लम तुम्हारा टोटल सिस्टम में भी चलेगा. So this is known as, so here we can say that means asynchronous, not at one time. Okay, and the behavior of asynchronous sequential circuit depend upon the input signal at any instant of time and the order in which input changes. मतलब हम उसको जो एग्जाम्पल में ऐसे समझा रहे हैं कि वो जो इनपुट जो फर्स्ट वाला पर्सन किस टाइम पे वो एंट्री कर रहा है और वो कितना टाइम ले रहा है उसके ऊपर डिपेंड करता है, तो बाकी सबका परफॉर्मेंस से डिपेंड करता है. तो वैसे ही इन द एसिंक्रोनस सर्किट, इफ द इनपुट सिग्नल एट व्हाट टाइम यू आर प्रोवाइडिंग and the order means suppose second order function or third order, that means if it is a complex input is we are giving, then depending upon the time requirement of the first one complete, the second one will be start. Then after completion of the second one, third one will be start. So it is just like a time delay. वो सिर्फ तुम्हारा टाइम को डिले कर रहा है. ये भी एक सीक्वेंस हो रहा है बिकॉज फर्स्ट वन के बाद सेकंड वन के बाद थर्ड वन ये हो रहा है. एंड सो दैट्स व्हाई इट इज अ सीक्वेंशियल सर्किट एग्जांपल. बट थिंग इज दैट नॉट एट वन टाइम and depending upon the input changes, output will be changing. So have you understood these two difference? Have you
Yes, ma'am.
understood? Okay. Then here it is written about the asynchronous circuit that the storage element commonly used in asynchronous sequential circuit are time delay device. So time delay device मतलब क्या है? देखो, we can say that if in the ये नहीं होगा. ठीक है. So this is your memory element. Can you see this memory element? This is the box of memory element. It is not properly drawn. This is the memory element, yes or no? Hello?
Yes, ma'am.
So if this clock pulse is not applied to the memory element, then that memory element is known as latch. Okay. And the sequential circuit which is containing the memory element as latch, that is known, generally used as the asynchronous circuit. Asynchronous circuit. So what is the meaning of that one? ये जो है क्या है? Clock pulse है. That clock pulse is applied to that memory, मतलब clock pulse मतलब एक particular time. तो अगर तुम्हारा टाइम पर्टिकुलर मेंशन नहीं किया जा रहा है तो वो मेमोरी जितना टाइम लेगा. देखो, ये तुम इनपुट दिए. ओके, सो इनपुट दिए तो सपोज 2 बिट का हमारा जो जैसे हम ले रहे थे 0 0 0 1 1 0 1 1 plus 1 sequence. Suppose we are accepting this one. So first output is getting what? 0 0. Yes or no?
Yes, ma'am.
First, then this 0 0 is applied to where? Memory element. Yes or no?
Yes, ma'am.
Then this total memory element, whatever it will be taking the time, अगर ये ज्यादा टाइम ले रहा है उसको सेफ, मतलब इसको ये क्या मेमोरी एलिमेंट को इनपुट होगा, फिर इसका आउटपुट इनपुट होगा कॉम्बिनेशनल को, तब जाके फाइनल आउटपुट मिलेगा. तो ये जो मेमोरी एलिमेंट जितना डिले करेगा इस इनपुट से आउटपुट तक, उतना सिस्टम का आउटपुट डिले होगा या नहीं?
हाँ.
तो वही होता है एसिंक्रोनस. एसिंक्रोनस मतलब एक टाइम तो हम नहीं दे रहे ना. अगर हम क्या करेंगे, पर्टिकुलर टाइम में सारा फंक्शन काम करेगा तो ये भी एक पर्टिकुलर टाइम पे और उसी टाइम पे ये भी काम करेगा, देन दैट वन इज नोन एज द सिंक्रोनस. बट एसिंक्रोनस मतलब इसका कोई टाइम हम लोग नहीं दे रहे हैं, ये ऑटोमेटिकली अपना टाइम ले रहा है. तो हम लोग बोल रहे हैं कि अगर ये ज्यादा टाइम लिया तो आउटपुट भी ज्यादा टाइम से कंप्लीट होगा, अगर ये कम टाइम लिया तो आउटपुट भी तुम्हारा कम टाइम होगा कि नहीं? Hello? Hello? Have you understood?
Yes, ma'am.
Okay. So, if the memory element we are not providing any clock pulse, then that one is known as latch, and latch is the example of your asynchronous sequential circuit. And if the clock pulse is applied to that memory element, then that memory element is known as flip-flop, but is written here, and that is the example of the synchronous circuit. So how it will be synchronous circuit? मतलब ये जो clock pulse दिया जाएगा, मतलब एक particular time दिया जाएगा. So at this time the output should come. So ये अगर आउटपुट आएगा तो उसी टाइम पे वो नेक्स्ट कॉम्बिनेशनल सर्किट को इनपुट जाएगा और उसी टाइम पे तुम्हारा आउटपुट निकलेगा. So कितना टाइम के बाद कितना टाइम में आएगा वो तुम्हारा कंट्रोल हो रहा है बाय द क्लॉक पल्स.
मतलब क्लॉक पल्स में क्या डिले का टाइम पहले से सेट किया जाएगा कि मैम इतना
क्लॉक पल्स तुम अभी तक पता है क्या? पता नहीं है क्लॉक पल्स क्या है? पता है?
नो मैम.
तो मैं क्लॉक पल्स बताऊंगी. क्लॉक पल्स क्या होता है? एक जो स्क्वायर वेव फॉर्म होता है, जैसे कि तुमने जो ये किए है एडीए प्लेग्राउंड में, तुम्हारा जो आउटपुट वेव फॉर्म, हैव यू गॉट दैट वन? एंड गेट और गेट आउटपुट वेव फॉर्म, यू हैव चेक दैट वन? अभी रिसेंटली जो तुम्हारा लैब में किए थे.
हाँ मैम, वेव फॉर्म.
तो हाँ, so that it is this clock pulse. The shape of the clock pulse is nothing but like this. Can you see this one graph? This figures. Can you see? Can you see these figures? This is one. This is one clock pulse. This is another clock pulse. This is another clock pulse. So clock pulse is nothing but sequence of 0 and 1s. Either, so here that means this is the 0, next 1, then 0, 1. It can be also known as, this is a train of pulses. So one pulse means one time cycle. यहाँ से इसको एक cycle बोलते हैं. Okay? That means positive as well as negative if it is continuing one cycle. Next cycle is positive and negative, another cycle. Then this positive, negative, another cycle. So train of pulses is known as clock pulse. Or we can say that the number of square waves also we can known as the clock pulse. And this positive, negative duration may be equal, may be unequal. Here positive labels, this one is very small duration, but this 0 is a high duration. So this is not symmetric. But you can also take the clock pulse of the symmetric clock pulse. That means positive label and the negative label both are having the same time. Okay. So these are the clock pulse. So clock pulse क्या होता है? So only, and this every clock pulse having either it will be label wise we can take the clock pulse or age wise. What is the meaning of that one? देखो एक जो ये जो क्लॉक पल्स थे इसको हम बोल सकते हैं लेबल है, ये तुम्हारा हाई लेवल, दिस इज द लो लेवल. अगेन दिस इज द हाई लेवल, दिस इज द लो लेवल. सो इसको बोलते हैं लेबल वाइज. ओके. एंड देन इसको बोलते हैं एज वाइज. व्हाट इज द एज? देखो ये है एज, दिस इज वन एज, दिस इज अनदर एज. अगेन दिस इज वन एज, this is another age. Okay. And this age is known as positive age because this one is 0 to 1. वो increasing order में हो रहा है, 0 to 1 positive age. And this one is known as negative age. That means 1 to 0 just coming. Again, this one positive age and this one is negative age. So you can look at what is written here. Response to positive label. What do you mean by that one? अगर तुम्हारा कुछ भी चेंजेस होगा या फिर हम जो इनपुट देंगे तो इनपुट मतलब क्लॉक पल्स देंगे. सो इसी टाइम पे रिस्पॉन्स टू पॉजिटिव लेवल, ये एक पॉजिटिव लेवल है, तो सर्किट का जो भी आउटपुट होगा ड्यूरिंग दिस पीरियड द आउटपुट विल कम. देन ड्यूरिंग दिस नेगेटिव लेवल देयर विल बी नो आउटपुट बिकॉज सर्किट तो काम ही नहीं करेगा क्योंकि क्लॉक पल्स का ये दिए है हम पॉजिटिव लेवल वाला क्लॉक पल्स. फिर नेक्स्ट जब पॉजिटिव लेवल वाला ड्यूरेशन आएगा उसी ड्यूरेशन में फिर से काम करेगा, फिर यहाँ पे काम करेगा. उसको बोलते हैं पॉजिटिव रिस्पॉन्स एट पॉजिटिव लेवल. अगर हम उसको सेट करेंगे नेगेटिव लेवल मतलब सिर्फ नेगेटिव लेवल में काम करेगा. मतलब ड्यूरिंग दिस ड्यूरेशन द आउटपुट विल चेंज लाइक दिस. ड्यूरिंग दिस ड्यूरेशन आउटपुट चेंज, ड्यूरिंग दिस ड्यूरेशन आउटपुट चेंज. हैव यू अंडरस्टूड और एनी डाउट? Any doubt? Ask me. Label trigger or response to positive label. Have you understood?
Yes, ma'am.
Yes, ma'am.
Like this, if we are applying the clock pulse as the A's response or A's triggering, उसको बोलते हैं ट्रिगरिंग. ट्रिगरिंग मतलब स्टार्टिंग. जैसे कि ट्रिगर दबाने से तुम्हारा जैसे शूट होता है, वैसे ही यहाँ पे क्लॉक को अप्लाई करने से तुम्हारा स्टार्ट होता है. सो दैट्स व्हाई द क्लॉक ट्रिगरिंग होता है. सो दिस इज पॉजिटिव एज ट्रिगरिंग, this is negative edge triggering. That means when we are applying the clock pulse, अगर तुम्हारा सेट किए हो positive edge triggering, that means only at this instant whatever the changes in the circuit वो होगा. Only at this instant. ये यहाँ पे नहीं होगा, फिर यहाँ पे भी नहीं होगा, फिर at this instant तुम्हारा चेंजेस होगा, फिर यहाँ से यहाँ तक नहीं होगा, फिर यहाँ से. देखो इसीलिए ओनली जो 0 to 1 थे तुम्हारा आरो मार्क दिया गया है, उसको बोलते हैं पॉजिटिव एज. मतलब एट दिस पॉइंट योर सर्किट विल बी रिस्पॉन्डिंग. व्हाट यू मीन बाय रिस्पॉन्डिंग? मतलब इसी टाइम में तुम्हारा जो इनपुट होगा वो आउटपुट को जाएगा. हैव यू गॉट दिस? देन ये अगर नेगेटिव एज होगा तो देखो एट दिस इंस्टेंट, at this instant, at this instant, at this instant, only at this point we are checking the output respond to the input, not all the time. Have you understood?
Yes, ma'am.
Okay. So if the time, basically the latch is, here it is written that latches are said to be label sensitive device and flip flops are age sensitive. मतलब तो जनरली का लैच में हम यूज ही नहीं करते हैं तुम्हारा क्लॉक पल्स. अगर भी करते हैं तो उसको लेबल सेंसिटिव, मतलब जब तक तुम्हारा क्लॉक हाई रहेगा तब तक तुम्हारा आउटपुट चेंजेस होता रहेगा, और अगर तुम्हारा 0 रहता है तब तुम्हारा आउटपुट नहीं आएगा. और जो फ्लिप फ्लॉप होता है उसमें जो क्लॉक पल्स देते हैं दैट इज एज सेंसिटिव. मतलब वो चेक करेगा कि पॉजिटिव एज ट्रिगरिंग है या फिर नेगेटिव एज ट्रिगरिंग है. अगर पॉजिटिव एज है तो पॉजिटिव एज को वो रिस्पॉन्ड करेगा, नेगेटिव है तो नेगेटिव एज को रिस्पॉन्ड करेगा. So here this is the time delay. Asynchronous sequential circuit are nothing but the time delay. Unless until we are getting the output of the memory, we cannot get the output of the sequential circuit, and that time is delayed by the memory element. So that is known as the asynchronous sequential circuit example. Then synchronous sequential circuit employs signal that affect the storage elements at only discrete instant of time. Discrete मतलब देखो at this point, next at this point, next at this point, next at this point. So discrete point we are applying the clock pulse to the circuit. The synchronization is achieved by a timing device called clock generator, which provides a clock signal having the form of a periodic train of clock pulses. So this clock signal, this is nothing but the clock signal, and these clock signals are generated by the device which is clock generator. The clock signal is commonly denoted by identifier clock or CLK. So this clock pulse को हम क्या लिख सकते हैं? CL और CK भी रिप्रेजेंट कर सकते हैं, नहीं तो CLK रिप्रेजेंट कर सकते हैं. The clock pulses are distributed throughout the system in such a way that storage elements are affected only with the arrival of each pulse. So मतलब तुम्हारा जो सिस्टम हो वो सिर्फ क्लॉक पल्स आने में ही वो चेंजेस होगा, अदरवाइज नहीं होगा. In practice, the clock pulse determine when the computational activity will occur within the circuit, and other signals determine what changes will take place affecting the storage element and output. So have you understood this line? In practice, the clock pulse determine when computational activity will occur. मतलब क्या है? मतलब क्या है? Have you understood this entire sentence? This one in practice, ये जो enter लिखा हुआ है, have you understood this one? Have you understood?
Yes, ma'am.
Can you explain?
Yes, ma'am. Only in that particular time interval, the inputs are going into the storage.
Only that thing is written. Any other answer? Any other answer? Here it is telling that the clock pulse determine when the computational activity will occur within the circuit. मतलब clock pulse का काम क्या है? वो सिर्फ डिटरमिन करेगा कब तुम्हारा स्टार्ट होगा. ओके. एंड अदर सिग्नल मतलब क्या है? जो इनपुट, एक्सटर्नल इनपुट. Yes or no? External input determine what changes will take place affecting the storage element and output. तो clock pulse का काम क्या होता है? अरे clock pulse का काम क्या होता है? समझ में आया कि नहीं? Hello, have you understood this entire statement? This is most important part. Shubham Kumar.
Yes, ma'am.
Where are you? At home?
Yes, ma'am.
Okay, background noise, so many background noise. Okay, so have you understood this sentence? Have you gone through that sentence?
Yes, ma'am. Yes, ma'am.
Explain करो. समझे नहीं हो, सिर्फ बोले हो. समझे हो तो अच्छी तरह से समझाओ.
जो क्लॉक पल्स है वो मैम डिटरमाइन करेगा वो इनपुट का वो इनपुट का जो टाइमिंग होगा उसको.
नहीं, यस मैम करके यही आंसर करोगे ना. हाँ, शुभम पटनायक. शुभम पटनायक. पुष्पेंद्र.
यस मैम. मैम एग्जैक्टली नहीं समझ में आया.
क्यों? मैं पूछी इसीलिए नहीं समझ में आया. तुम तो मुझे नहीं पूछे. ओके. So meaning is that इस डायग्राम में, in this diagram explaining, okay, here in this diagram, okay, here it is telling that where clock pulse is applied. Tell me from this one where the clock pulse is applied. कहाँ पे clock pulse apply हो रहा है? अरे क्लॉक पल्स कहाँ पे अप्लाई हो रहा है? कॉम्बिनेशनल सर्किट पे या फिर मेमोरी पे?
मेमोरी पे.
हाँ, तो ये है तुम्हारा क्लॉक पल्स. ओके. सो इट इज टेलिंग दैट व्हेन द क्लॉक पल्स अप्लाइड देन एंटायर सर्किट ऑपरेशन स्टार्ट्स. लेकिन जो ऑपरेशन जो चेंजेस हो रहा है, मतलब अगर मेमोरी का कंटेंट 0 था, अभी जो 0 1 हुआ, वो क्या ये क्लॉक पल्स के वजह से हुआ या फिर इनपुट के वजह से हुआ?
इनपुट के वजह.
हाँ, तो वही बोल रहा है कि क्लॉक पल्स सिर्फ तुम्हारा टाइमिंग सेट कर रहा है. एट व्हाट टाइम योर ऑपरेशन स्टार्ट्स, बट your whatever the changes of the memory content, that will be depend upon the input. The clock pulse has no effect on that one. हमें सिर्फ चाहिए कि कौन से टाइम पे तुम इनपुट आया, कौन से टाइम पे इनपुट गया, फिर कौन से टाइम पे मेरा फाइनल आउटपुट आया. ओनली टाइम सीक्वेंस. एंड क्लॉक पल्स जब तक तुम्हारा अप्लाई नहीं होता तब तक वो टोटली स्टार्ट ही नहीं होगा. वंस यू अप्लाई दैट विल बी स्टार्ट. एंड वो स्टार्ट होने के बाद जो प्रोसेस होके वो चेंजेस आ रहा है दैट विल बी डिपेंड अपॉन द इनपुट. वो क्लॉक पल्स चेंज नहीं कर रहा है. हैव यू अंडरस्टूड? अंडरस्टूड? जैसे कि तुम्हारा तुम जो ईडीए प्लेग्राउंड में यू हैव सीन द आउटपुट वेवफॉर्म. हैव यू सीन एंड गेट? यस और नो? So you have given that #1 say in the program of the test bench, one symbol was #1. Then input you are assigning 00 again #1. Have you seen? Or forgotten? Hello, nobody
Yes,
has.
ma'am. On the time period.
हाँ, तो मतलब जब तक 1 सेकेंड नहीं हो जाता है तब तक वो इनपुट को रिस्पॉन्ड ही नहीं कर रहा है. तो 1 second after that one, according to the input, output is changing. So that is the what? That is the time providing. That is the clock pulse. Okay, when the clock pulse start, so that clock pulse वो वहां पे 1 second था. यहाँ पे आइदर तुम पॉजिटिव वेव ट्रिगर करोगे, नहीं तो नेगेटिव वेव ट्रिगर करोगे, नहीं तो तुम पॉजिटिव लेबल ट्रिगर करोगे, नहीं तो नेगेटिव लेबल ट्रिगर करोगे. सो कौन से हिसाब से होगा उसी टाइम के हिसाब से तुम्हारा चेंजेस होगा. ओके. Next thing is the storage element. There are two types of storage element. One is latches, another is the flip-flop. So, and latches is the label triggering. That means if normally latches are not requiring any clock pulse, or if you are saying that if it is requiring clock pulse, then it will be label triggered clock pulse. And this flip-flop is your ACE triggered flip-flop. Okay. So. So first I am explaining this one, then so this is the circuit diagram of SR latch. So latch, this entire circuit is the circuit of the latch. That can you tell me this entire circuit is the block diagram of what in the main sequencer circuit? The sequencer circuit consists of two blocks. What are those two blocks?
कॉम्बिनेशनल ब्लॉक है, मेमोरी ब्लॉक.
वेरी गुड. तो ये कौन सा ब्लॉक है? ये जो सर्किट है कौन सा ब्लॉक है? दिस इज लैच. मीन्स hello, latch means which block?
Memory block.
So this entire circuit is nothing but memory unit. Okay, and we are knowing that the memory unit is storing how many bit? How many bit? No. 1 bit. One memory element is storing 1 bit. For 2-bit cases, 2 memory element. Like this, we can use 3-bit cases, just like suppose one counter. If it is counting from 0 to 9, then it will be 000 to 111. So first content is 000. So 3 zeros. One memory location or memory element is containing only 1 bit. Only 1 bit. So there are two options are there. Either it will be storing 0 or it will be storing 1. So there are 3 bits means 3 memory elements. Like this, suppose your processor, your microprocessor or your laptop, you are using some processor. So that will be having 64-bit register, 64-bit memory. So in that case, 64-bit means binary 64 bits are there in form of 0101. And as only 1 bit is stored by one flip-flop, so we can use 64 flip-flops are in cascaded to store 64 bit. Have you understood? Have you understood?
Yes, ma'am.
So only one bit will be stored by the one memory element, and this is the memory unit or diagram. And this memory, as it is one bit, so this bit will be stored by the Q. Here it is looking that it will be two outputs are there. One is Q, another is the Q bar. But this Q bar is nothing but complement of this Q. It is not another two states. We can say that. जो भी आएगा वो Q में रहेगा. अगर हम बोल रहे हैं कि जीरो स्टोर होके रहता है, that means Q value should be 0. अगर तुम्हारा मेमोरी में 1 स्टोर होके रहता है, so that should be Q value is 1. And we have to check that अगर Q 0 होगा तो Q dash 1 होगा, अगर Q 1 होगा तो Q dash 0 होगा. Okay, only one output. Okay, we are considering. Then two inputs are there. Why? Because actually in the memory, what actually it can be stored 1 or it can be stored 0. But we are controlling that memory. That means suppose I want that memory content should be 1, or I want that memory content should be 0. So now tell me that suppose if you are controlling that memory content, that will be benefit, or if you are not controlling that memory content, that will be benefit. क्या आएगा? कौन सा बेनिफिट होगा? Hello. Okay, so what was the question? Question was, suppose we control the memory, is it benefited, or if you are not controlling the memory, it will be benefited? Who can answer? Hello? Hello? Am I
Yes,
audible?
ma'am. Yes, ma'am.
तो कौन सा benefit होगा?
Ma'am, controlling.
Obviously, because suppose, for example, already I have told that one. Suppose you want that for responding your response, you have set your कोई भी buzzer जैसे होता है, buzzer जैसे होता है हम on कर देते हैं. जब तक वो respond नहीं होता है, वो buzzer on होके रहेगा. और जब वो respond हो जाएगा, वो off हो जाएगा. फिर till अगर किसी का कोई जरूरत होता है, फिर वो वही buzzer बजाएगा. लेकिन अगर हम लोग क्या उसका कंट्रोल नहीं करेंगे तो वो खुद से ही ऑन ऑफ होता जाएगा. तो इसका मीनिंग भी कुछ पता नहीं चलेगा कि वो एक्चुअली चाहते हैं या नहीं चाहते. तो इन दैट केसेस, लेकिन एक चीज है कि तुम्हारा जो ऑन ऑफ जो होगा मेमोरी विदाउट कंट्रोलिंग, वो जल्दी से तुम्हारा काम करेगा क्योंकि विद इन शॉर्ट पीरियड ऑफ टाइम अगेन द वैल्यू विल बी चेंजिंग. बट हियर that will be taking much time, because unless until your respond will be there, that will not changes. तो इसीलिए वो टाइम टेकन लगा, बट इट शुड बी कंट्रोलिंग क्योंकि तुम्हारे रिक्वायरमेंट के हिसाब से वो मेमोरी काम करेगा. इफ यू वांट दैट आउटपुट विल बी 1, so that will be 1 unless until any other input we are providing. But in uncontrolled cases, automatically if the input changes, output will be changing. Okay. So first we are discussing about the uncontrolled one, then we are discussing about the controlled one. So this one is the example of the uncontrolled one. Okay, that means we are not giving any clock pulse. And when you are applying the clock pulse, that means timing signal, then it will be controlled one. Okay. So here this is two inputs are there. Why two inputs? Because either we want to set that output or we want to reset that output. So for set that output, the output should be 1. And for reset that output, the output should be 0. So that can be obtained by the two inputs. One is S, another is the R. Then now we are discussing the working condition of your SR latch. Okay. So now can you see this one? Here two input, this one input is R, this one input is S. This one is NOR gate. This is one NOR gate, this is another NOR gate. This one is known as latch is the circuit with two cross-coupled NOR gates or two cross-coupled NAND. Cross-coupled means, देखो, output of this NOR gate is feed to the input of this NOR gate. And output of this NOR gate is fed to input of this NOR gate. So that's why cross-coupled NOR gates. Can you see the diagram? Hello?
Yes, ma'am.
Okay. Then, as this is NOR gate, then tell me what is the NOR gate, NOR truth table? When both are 0, 0, output is? Output is?
1.
1, NOR. No problem, NOR. Okay, so output is 0, input is 0, 0, output is 1. Input is 0, 1, output is 0. 1, 0, output is 0. And 1, 1, output is 0. Yes or no? That is the truth table of NOR. NOR gate. Okay. So here, as this is NOR gate and we know that any of the input is 1, then output is 0. So let it be S value will be 1. Suppose S value we have taken as 1. Then whatever may be the value input to this one. Okay. Whatever may be the value, we don't bother. What should be my output? अगर एक भी input तुम्हारा 1 होगा, तो output क्या आएगा? आउटपुट क्या आएगा? One of the
0.
आउटपुट आएगा 0। तो दिस 0 यहाँ पे 0 आएगा। दिस 0 इज फीड हियर द इनपुट हियर। यहाँ पे हम ले रहे हैं 0 1। सपोज फर्स्ट कंडीशन आई हैव टेकन एज r इज इक्वल टू 0 एंड s इज इक्वल टू 1। तो ये जब 1 दिए तो यहाँ पे 0 आ गया। तो ये 0 जब यहाँ पे गया तो 0 0 आउटपुट क्या आएगा? 1। तो देखो अगर हम s को 1 किए तो आउटपुट q मेरा आउटपुट है, तो q में क्या आया? q में क्या आया? 1 आया। मतलब if the set input is active then output should be 1. Okay, now this output suppose मेरा 1 है तुम्हारे आउटपुट में। अभी ये इनपुट को मैं चेंज कर रही हूँ, 1 to 0 कर रही हूँ। ओके, तो अभी देखो इसी कंडीशन में, मतलब तुम्हारा सपोज आउटपुट 1 0 है, इसी कंडीशन में मैं जो इनपुट पहले दी थी 1 0, अभी मैं उसको चेंज कर रही हूँ 0 0। तब देखो क्या होता है, ये 0 है, ये 1 यहाँ पे आएगा, तो 0 1 का आउटपुट क्या आएगा? 0 1 का आउटपुट 0। फिर ये 0 यहाँ पे फीड होगा, तो 0 0 का आउटपुट क्या आएगा? 1। तो पहले प्रीवियस स्टेट में क्या था? q डैश
0।
नहीं, q डैश क्या था? 1 0 था।
यस मैम।
अभी क्या आया?
1 0।
मतलब जब हम इनपुट को 0 0 देते हैं तो आउटपुट क्या रहता है? नो चेंज। हैव यू अंडरस्टूड? हैव यू अंडरस्टूड? ओके, नाउ अभी हम लोग क्या देखें कि सेट को अगर 1 करते हैं तो q वैल्यू 1 आता है। अभी हम क्या देखेंगे, रिसेट को अगर 1 देते हैं तो क्या आएगा, वो चेक करेंगे। Okay, so now I am giving reset value is 1. So at that moment set value is 0. So with reset value 1, whatever may be the input to this NOR gate, output क्या आएगा? क्योंकि 1 आउटपुट 0 आएगा, और ये 0 के साथ अगर मैं इसमें 0 डालूंगी तो इसका आउटपुट क्या आएगा? 1। तो अभी देखो जब मैं रिसेट को 1 दी तो मेरा आउटपुट क्या आएगा? 0। मतलब तुम्हारा मेमोरी रिसेट हो गया, मतलब 0 कंडीशन में आ गया। ओके, अभी इसको 0 1 रख रही हूं, अभी इस 1 को मैं 0 कर रही हूं। अभी स्टार्ट करो। सपोज यहां से स्टार्ट कर सकते हो, नहीं तो यहां से भी स्टार्ट कर सकते हो। सपोज मैं यहां से स्टार्ट कर रही हूं, तो 0 with 0 क्या आएगा? 1। ये 0 है ना, ये 0 यहाँ पे आया, ये ऑलरेडी 0 है, तो 0 0 ये आएगा 1। ये 1 यहाँ पे जाएगा, तो 1 0 क्या आएगा? यहाँ पे 0। मतलब प्रीवियस स्टेट था तुम्हारा 0 1, अभी जब तुम 0 0 कर रहे हो तब भी तुम्हारा क्या आ रहा है? 0 1। दैट मीन्स व्हेन द इनपुट इज 0 0, आउटपुट इज नो चेंज। हैव यू अंडरस्टूड? हैव यू अंडरस्टूड?
यस मैम।
एंड नाउ अनदर कंडीशन इज, अभी हमारा 0 0 हो गया, 0 1 हो गया, 1 0 हो गया। लास्ट कंडीशन क्या है? 1 1। 2 वेरिएबल्स मतलब 4 कंडीशंस वी हैव टू चेक। सो लास्ट कंडीशन इज 1 1। देखो कोई भी आउटपुट ले लो, कोई भी आउटपुट, मतलब सपोज 0 1 पहले है तो उसी को लेके हम करेंगे। तो ये अगर 1 इनपुट है और 0 यहां से आया तो 1 0 क्या होगा? 0 होगा कि नहीं? अरे जब इनपुट 1 है और ये प्रीवियस आउटपुट को हम 0 ले रहे हैं, तो दिस 0 and this input is 1. So 2 inputs are feeding to this NOR gate, so output is 0. And this 0 is coming here. यहाँ पे इनपुट क्या है? 1 है, तो 1 0 में अगेन यहाँ पे क्या आएगा? 1 0 पे 0। तो Q बार क्या आ रहा है?
0, 0.
Which is not possible because we are taking q bar should be one, complementing each other. Yes or no? हम लोग ले रहे हैं q जो आएगा q बार तुम्हारा उसका कॉम्प्लीमेंट होगा लेकिन यहाँ पे सेम आ रहा है तो दैट्स व्हाई ये दिस कंडीशन इज द फॉरबिडन दैट मींस नॉर्मली वी आर नॉट टेकिंग दिस कंडीशन यहाँ पे देखो सपोज s is 1 r is 0 then q value is coming as 1 q dash is 0 and with that condition if I am changing the input is 0 0 it will be remain as that like this when r is 1 s is equal to 0 your q value is 0 and this is 1 and with this condition if I am giving the input is 0 0 output will remain same and when we are giving the input is 1 1 the output both are not complementing each other so this condition is the forbidden condition so this is the concept of memory that means if we are giving any input अगर हम set को देंगे input तो output 1 आएगा अगर हम reset को देंगे input तो हमारा 0 आएगा अगर हम input को 0 0 दे देंगे तो हमारा previously जो भी condition होगा जो भी content होगा वो तुम्हारा same रहेगा ओके एंड अगर 1 1 दे देंगे तो वो काम ही नहीं करेगा ओके हैव यू अंडरस्टूड okay I have sent the link of quiz so do this one have you got it
Yes, ma'am.
Yes, ma'am.
okay do it So what about your exam? Any other notice came?
No, ma'am.
No, ma'am.
Mhm. So prepare as much as possible the short question type question. Okay, so from the in the Google also you just type that MCQ on any topic and practice as much as possible. And if it will be from 17th, then best of luck for that one. Okay, thank you all. We will submit your quiz.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Okay, ma'am.